Hi everyone, this is our entry for the SAP Lumira competition. Our group is called Mage Enterprise, which provides a visual analysis and interpretation of datasets. The topic we have chosen are CO2 emissions, which is an area of interest that has always been discussed in media. Through the analysis conducted, it was evident that various factors affect CO2 emissions. For the purpose of this presentation, we will use 5 storyboards depicting the different aspects, such as years, country, income group, access to electricity, and electricity usage. Our first storyboard looks into CO2 emissions throughout the years. We can identify that in 1960, the highest emitter of CO2 are Luxembourg. However, this dramatically changed in the span of 50 years, with Qatar being the highest emitter by 1980 to 2010. Further research indicates that Qatar is the largest exporter of liquefied natural gas, which supports the large contribution of emissions. Now let's take a look at our second storyboard, which focuses on CO2 emissions by country and region. Looking at the heat map, we can identify that the highest emitter is in Middle East and North Africa, which is where Qatar is located in. We can also see Sub-Saharan Africa, specifically Uganda, to be the lowest emitter. This is because Uganda's main exports, such as coffee, barely contribute to CO2 emissions. The table also illustrates a general idea on the CO2 emissions of regions measured in metric tons per capita. The column graph further depicts the notion of emissions and region, once again presenting the highest and lowest emitters.
Our third storyboard looks at CO2 emissions according to their income group. These 3 graphs demonstrate the correlation between the emissions produced in certain countries and the income group to which they belong in. We start off with Graph 1, a geography map, which shows the average CO2 produced by country and income group. On the right-hand side of this graph, we have a legend depicting the size and colors of the circles. The size of the circles represent the average amount of CO2 emissions produced by that country, whereas the colors show the income group from which that country comes from. When you move the cursor over a circle, the income group and average CO2 of that country is displayed. So for example, we have the United States, whose country belongs in the high-income OECD group, which stands for the Organization for Economic Cooperation and Development. The United States also has an average of 19.76 metric tons per capita of CO2 emissions produced. Our next example is Mongolia. This country belongs in the lower to middle income group and produces an average of 3.39 metric tons of CO2 emissions. We assume that the countries with lower incomes tend to use less resources and therefore burn less fuel containing carbon. The bar graph below represents similar information as above. However, we are now looking at the income group within the region as a whole instead of just the country. On the left, we have the income groups, the bottom we have the average CO2 emissions produced, and the colors represented in the graph are the regions which can be sorted out on the right-hand side with the legend. A large percentage of the high-income non-OECD group is orange, and if we click on that, we can see that the average amount of CO2 emissions produced is 125.39 metric tons out of the 250 plus in the Middle East and North African region. Within the high-income OECD group, the green area is strikingly alarming as it takes up more than half of the CO2 emissions produced. The region of Europe and Central Asia produces an average of 164.30 metric tons. You can also click on the region which results in its values being highlighted. Here we have clicked on the Sub-Saharan Africa region. As you can see, this region produces a small amount of CO2 emissions compared to other regions. We believe so due to the fact that a majority of countries from this region are suffering from poverty and do not have the same amount of resources as countries that are better off. Our last graph on this storyboard is a table outlining the highest and lowest average CO2 emissions produced with their associated countries and income group. The country with the highest individual amount of CO2 produced is Qatar, with a whopping amount of 55.79 metric tons. Qatar belongs in the high-income non-OECD group. The country with the lowest amount of CO2 emissions produced is Uganda, with only 0.7 metric tons per capita. Uganda belongs in the low-income group. Through these graphs, we have justified that countries belonging to a higher income group are more likely to produce more CO2 emissions due to being economically stable and having resources. Next, we have our fourth storyboard, which presents the relationship between CO2 emissions and the access of electricity within a specific region and income group. For our first graph on this storyboard, we have created a funnel graph depicting the average amount of electricity access within a region, as well as hovering the cursor over specific colors on the funnel. There is a key to the right-hand side showing the region and its corresponding color. So as you can see, the region with the most access to electricity is Latin America and the Caribbean, with an average electricity access of 1,862.10 units. In saying this, electricity access isn't defined only by the first supply connection of the household. It also depends on the location, specified minimum level of electricity, and the amount of people within each household. Moving on, we have the second highest region that contains electricity access to be the Middle East and North Africa with 1,719.90 units. As we move down along the funnel, the corresponding region and amount of electricity access is displayed. In the second graph, we analyze three characteristics. The y-axis measures the amount of electricity in metric tons per capita. The x-axis displays the name of each region, and the colors of the columns depict either the CO2 emissions produced or the amount of electricity accessed in the year 2010. If we drag our cursor over the column, which represents the highest amount of electricity access, we are able to see the exact amount. You can also do this for the other columns too. There is no direct correlation between having more electricity access with the amount of CO2 emissions produced. Just because they have access to it does not mean they use it, which is shown in this column graph. Our last graph demonstrates CO2 emissions and electricity access, also in the year of 2010, but this time with the income groups. The middle to high income groups, whether they are OECD or non-OECD, have no specific correlation in terms of CO2 emissions produced and the amount of electricity they have access to. However, as stated in the previous storyboard, low income generates lower CO2 emissions being produced. Lastly, we have our fifth and final storyboard, which outlines the amount of CO2 emissions produced and the amount of electricity actually being used by both region and income groups. So here we have the average usage on the left-hand side, the corresponding amount of CO2 emissions produced on the right, and the region down the bottom. Again, the colored key depicts the average electricity usage in red, and blue demonstrates the CO2 emissions. The region that contains the highest amount of electricity consumption is Europe and Central Asia. If you drag the cursor over the columns, you can once again see the specific amounts of usage and CO2 emissions being produced. Additionally, South Asia has the least amount of energy usage, therefore the CO2 emissions will be minimal. From this graph, we can conclude that the energy use correlates with the generated amount of CO2 emissions. The second graph represents the income groups and their associated electricity use. Whilst dragging the cursor, we can see that the highest percentage of usage is taken by the high-income OECD group, and the lowest percentage is occupied by the low-income group. We can then infer that the higher income groups they are more likely to afford resources, which enables them to utilize them as well. Our final piece to the puzzle is a table indicating the average energy consumption by specified region. Here there are direct numbers which enable us to visualize which region uses the most energy and produces the most CO2 as well. This can then assist in lowering our carbon footprint. By identifying and analyzing the problem, we are one step closer to figuring out a solution.